Germany reveals DroneHammer counter-drone system to protect troops from swarm attacks. At Enforce Tac 2026, Germany's Mosulf Special Vehicles presented the DroneHammer counter-drone system mounted on a Toyota Hilux pickup. The system is designed to neutralize small FPV and Class 1 drones flying up to 250 km per hour at distances reaching 2,000 meters. It targets the 100 to 1,200 meters layer of air defense, where jamming is often ineffective and small explosive drones threaten troops, vehicles, and infrastructure. Mosulf Special Vehicles showcased the DroneHammer counter-UAS system mounted on a Toyota Hilux pickup, marking an expansion of its activities in security-relevant special vehicles and protection solutions. The business unit, which includes B&T Solutions GmbH, Mosulf Special Vehicles GmbH, and Stuff International GmbH, focuses on special vehicle construction, armoring, and integrated protection concepts for defense, security, and infrastructure protection. At the exhibition, a representative said that the Hilux could be armored by Stuff and that the DroneHammer was presented in cooperation with Skylance GmbH. The mobile interceptor system targets small unmanned aerial systems, including FPV drones, and is developed as a response to evolving threat scenarios affecting vehicles and critical infrastructure. Pre-series models are scheduled for availability in Q4 2026, while the launcher configuration on display remains at Technology Readiness Level 4, TRL4. The DroneHammer is configured as a precision counter-drone missile equipped with a laser-guided optical seeker for target acquisition and guidance. The interceptor has a maximum range of 2,000 meters, a weight below 1 kilogram, and is intended for engagement of Class 1 drones with a focus on limiting collateral effects. Its effect mechanism relies on a CO superscript 2 base system that generates a fragmentation cloud with a radius of 10 meters, producing a shotgun-like pattern without the use of conventional explosives. An optional parachute recovery function mitigates ground impact risks following an intercept sequence. The interceptor is engineered in Germany and positioned for the 100 to 1,200 meter engagement segment as a last-layer air defense effector. Cost per intercept is identified at €2,500, forming part of the cost-effectiveness positioning of the concept. The launcher mounted on the vehicle consists of two groups of 6 tubes, totaling 12 launchers derived from Vision 60 counter-UAS launchers that are often paired in 2-unit sets. This modular multi-missile architecture supports integration into existing command and sensor networks, including NATO command and control structures, and is compatible with external detection assets. The current prototype is assessed at TRL4, with scalable configurations under development for both vehicle-mounted and portable employment. The system engages targets flying at speeds up to 250 km/h, with an interceptor system speed of 600 km per hour and a time to target of less than 4 seconds from detection to neutralization. The operational sequence follows detect, fix, engage, and neutralize phases, beginning with external sensor cueing and laser designation before autonomous terminal guidance. Integration into software-defined architectures enables plug-and-play incorporation into existing force structures. The DroneHammer system addresses cost asymmetry between low-cost drones and higher-cost conventional interceptors. Hostile FPV drones are identified at $500 per unit, while traditional defensive interceptors range from $40,000 to $450,000 per engagement, constraining sustained defense against mass attacks. The 100 to 1,200 meter perimeter is identified by Skylance as a critical gap in layered air defense where rapid response is required. Electronic countermeasures encounter limitations against autonomous and fiber-optic guided drones, reducing the effectiveness of jamming in certain scenarios. Therefore, the DroneHammer is configured as a kinetic interceptor intended to operate when electronic warfare measures are ineffective or insufficient. The system is designed to restore cost balance by enabling repeated engagements at €2,500 per intercept without reliance on high-cost munitions. Broader drone activity in Europe reinforces demand for short-range countermeasures. For instance, German airport authorities recorded 172 drone incidents by the end of September 2025, compared to 129 during the same period in 2024 and 161 for the full year 2024, indicating increased operational disruption in civil aviation. Legal frameworks in Germany restrict the use of firearms against drones due to risks from falling projectiles, and jamming systems risk interference with civilian telecommunications and police networks. In operational theaters such as Ukraine, monthly drone losses reach 200,000 units, with annual demand projected at 10 million systems, reflecting industrial-scale consumption. Both Ukraine and Russia have expanded domestic production capabilities, including flight control units and propulsion components, while supply chain linkages include Chinese battery technology transfers. These trends reinforce the need for rapid, short-range kinetic interception within layered air defense architectures. The DroneHammer is integrated onto a Toyota Hilux, which itself has evolved from a civilian medium-sized pickup truck introduced in 1968 into a recurrent choice for military and security applications across multiple regions. Its body-on-frame construction, based on a ladder chassis combined with durable suspension systems and four-wheel drive configurations, enables sustained use on unprepared terrain, desert tracks, and degraded road networks. The Hilux's mechanical simplicity allows maintenance with limited tooling, while its global production scale ensures widespread spare parts availability through civilian supply chains. In past conflicts, including the 1986 to 1987 Chadian-Libyan War, often referred to as the Toyota War, Hilux and similar Toyota 4x4 vehicles supported highly mobile operations where fuel consumption of 10 L/100 km contrasted with 200 L/100 km for heavy armored units. This combination of mobility, logistical efficiency, and low operating cost contributed to its adoption by state forces, irregular units, and security services operating in resource-constrained environments. The open cargo bed and reinforced frame facilitate rapid conversion for troop transport, logistics, reconnaissance, and weapons carriage, without complex structural modification. Beyond improvised adaptations, the Hilux has also been incorporated into structured defense fleets where light tactical mobility is prioritized over heavy armor. Its payload capacity and flatbed layout enable installation of machine guns, anti-tank guided missile launchers, air defense systems, or surveillance equipment, transforming the pickup into a mobile base for weapon systems or sensor packages. Specialized companies such as STUF provide ballistic protection packages, including armored cabins and reinforced components, allowing integration into higher threat environments while retaining off-road performance. The vehicle's civilian origin reduces acquisition costs compared to purpose-built armored vehicles, and life cycle expenses remain comparatively low due to standardized commercial components. Several armed forces in Europe and other regions have procured Hilux variants for liaison, patrol, and support roles, replacing older light utility fleets with commercially derived alternatives.